everybody. Happy Thursday. How are y'all doing tonight? Before we do jump into the topics of the evening, if you're like, who the heck is this guy? I'd love to start by telling you just a little bit about myself. My name is Ryan, and I'm the lead engineering instructor here in our East Coast remote immersive program. So that means that I lead our East Coast team. I teach about a third of the core curriculum lectures to our residents here on the East Coast. And I also work as an engineer for Codesmith's public-facing websites, including CSX. I'm sure many of you are familiar with CSX, as well as our internal tools. Let us now talk about classes, prototypes, and object-oriented programming, the content that's brought us all here together this evening. As a starting place, object-oriented programming is one enormously popular paradigm for structuring code. But I want to note that JavaScript is a multi-paradigm programming language. A paradigm is just a way of programming, a style of programming. So an example of a different paradigm, which we will not be discussing tonight, is functional programming, which prioritizes pure functions that isolate data from functionality. But for tonight, like we all know, our focus is going to be on object-oriented programming, which is a fundamentally different approach to structuring code. And in fact, one of its key features is that by design, we find data and functionality living side by side. So in this little like hand dance, if you see me do this at any point tonight, one hand represents data and the other hand represents functionality. And in OOP, we have a paradigm where data and functionality are living side by side in harmony, as we're going to see this evening. And there are tons of benefits to structuring our code in this way with data and functionality side by side. For one thing, because they are inextricably linked, they're packaged together in a way that makes it easy for us to add features and functionality that operates on our data. I mean, I'm sure most of you know how easy it is to work with JavaScript, work with objects in JavaScript. We can use bracket notation to work with objects in JavaScript, or we can use dot notation to work with objects in JavaScript. So it's quite easy adding new functionality to an object just using dot notation. But even beyond that, this style of programming is also going to make our code more performant, more efficient in terms of memory. And lastly, for now, following any recognized paradigm, but especially following this object-oriented paradigm, allows developers to write code that is readable and maintainable, that is easy for us and for other developers to read and reason about. It's got a clean structure. So we're going to have the chance to see some of these behaviors in action this evening. So let's go ahead and get into it, starting with an overview of what our goal is going to be tonight, what we're going to be doing tonight, which is building a quiz game with users. And eventually, we hope that this quiz game is going to have a whole lot of users, thousands of users, maybe millions of users. But, humble beginnings. For now, it looks like we currently have 2 users, one named Alex and one named Jason. And they've already answered some questions. There's already some score data affiliated with them. Alex currently has a score of 3, and Jason currently has a score of 6. And within our quiz game, in any real world quiz game, we would definitely have some functionality that we'd want to be able to apply to each user in our application. And in reality, there'd be probably a lot of different relevant functionality for each user. There's some examples here, like we might want to be able to increase the score, decrease the score, some user-related functionality like deleting a user or logging in, logging out, adding an avatar for a user, getting a user score. There are literally hundreds of possible features or pieces of functionality that we might want to apply to a user. But for tonight, we're going to focus on this ability to increase the score of a user in our application. So right now we've got some data here. We've got each user's name and score. And now we're going to also introduce some functionality into the mix. So let's see here. Christian, coming to us live from Texas, what do you think might be a good way for us to store these things together in one place? Like what's a data structure in JavaScript that allows us to store data and functionality in one package?
I'm guessing an object.
Yeah, an object, absolutely.
Data and functionality.
Totally. So we could store each of these users, their affiliated data, in an object. And, maybe Alex, as she's like playing this game, answers a quiz question correctly. We see that her score is currently 3. So if she answers a question correctly, we're going to need a way to increase that score from 3 to 4, which means that we're probably going to need some kind of increment method that contains a set of instructions that are going to allow us to increment that functionality for just one user. So we're going to need some kind of function definition, some set of instructions that's going to allow us to target the score for Alex. So this is really the question that's going to drive the rest of this conversation, is what's going to be the best way for us to package up this data, Alex's name and score, with this functionality, the ability to update that score in real time in our application. So like Christian said, an object is a great way for us to store that data and functionality side by side. An object stores, it encapsulates functionality with its associated data. It's known as the principle of encapsulation. So, getting back to our quiz game, we said that an object is the perfect data structure for storing this quiz game data, information about our users alongside the functionality we want our app to have. So how do we create objects? Well, there are a few different ways for us to do that. We see on the slide here the simplest way, which is using an object literal. And using an object literal means that we literally write out the curly braces and we manually fill them in with a series of key value pairs. And then inside of those curly braces, we can see, in this case, we've already added some properties, these key value pairs corresponding to the data and functionality that we want this object to store. So let's see here. How about Rochelle, do you think you could kick us off this evening? Can you just walk us through this object here using your best technical communication, just kind of walking us through what's going on in this object?
Yeah, just kind of read it out.
Yeah, absolutely.
So we've declared a variable constant user1 in the value, then we open the brackets. So then we have item, we're saying that the value of name is going to be Alex, and that's in quotation marks to specify that it's name. Then you have the value of the variable score, which in this case is a number of 3. Then you have the variable of increment, which then opens into a function. And I can't do this one, or I don't know what to call this part. But yes, that's as far as I can go.
Yeah, and you did an excellent job. That was exactly what I was looking for. Like Rochelle said, we see here we've declared a const user1. So we've declared a const with a label of user1, and we've assigned it the value of this object literal, right? These curly braces that we've populated with some key value pairs. And just like Rochelle said, we have a key of name, which has a value of Alex, which is a string in this case. We have a key of score, which is storing a value of 3, like Rochelle said, a number. And then the last property here is increment. And we see that we've assigned it the value of a function definition. And we'll talk a little bit more about that later on. But since this function definition is living inside of an object, we know that it can also be called a method, a function that's living on an object. And I would love to phone a friend here. Does anyone want to jump in here and let us know what they think is going to happen? Is running this final line of code going to be successful? When we run user1.increment, are we going to be able to target Alex's score and increment it from 3 to 4? Rochelle, if you know, feel free to jump in. Do you have a guess?
Yes, the answer should be true.
Yeah, absolutely. You're totally right. When we call this increment method, which is living on our user1 object, we're able to target. We can see the function definition here. We'll look at the score property on our user1 object, and that's going to allow us to target this score of 3 and increment it to 4. Right? And that's because we've got this object literal here, right? It contains both of these properties. It's got the score data. It's got the increment functionality. So going forward, this final line of code here is going to be a part of all of our approaches to this problem. And it's the metric we're going to use to figure out whether our approach is a good one and whether it's working. So with each of our subsequent approaches, we are going to evaluate this call to user1.increment to confirm that it's working as expected. So Rochelle, thank you so much for kicking us off with this first walkthrough. You've helped us confirm that this first approach using an object literal is one very simple way for us to create an object that has data as well as some usable methods, some usable functionality. Another valid object creation method is to instantiate an empty object and then to simply use dot notation to populate that empty object with data and functionality. So let's see here. Samuel, would you please walk us through this code with your best technical communication, just sort of what we've got going on in this code snippet?
Okay, so we are going to declare a constant labeled user2, and we're going to assign it the value of an empty object. And then in our following lines of code, we're going to populate that object using dot notation. And so in user2.name, we're going to create a key on the user2 object and set its value to the string JSON. User2.score is going to create the key score and assign a value of the number 6. User2.increment is going to create a method, and it's going to create a function definition that follows as user2.increment the score. And then after we finish populating our object, we are going to invoke the increment method in the line user2.increment.
Yeah, absolutely. And is that invocation of increment going to pass the test? Are we going to successfully increment the score from 6 to 7?
I would say so, yes.
Yeah, I totally agree with you, because when we call this increment method on the user2 object, we can see the function definition defined directly above. All we're doing is a direct key lookup in this user2 object. We're looking at the user2 object for a property called score, which we find here, right? We've got a score property. The value is currently 6. And all we're doing is incrementing that number from 6 to 7. So Samuel, that was fantastic technical communication. Just one kind of addition I want to make, or one detail I want to add into the mix here, is that on each of these lines of code, we're really sort of asking a question. Like when we see this code here, user2.name, we're sort of asking a question, which is, does user2 currently contain a property called name? And just to ask you, Samuel, if this like user2 object wasn't empty, if instead it already had a name property with a value of Samuel, what would happen when this line of code runs?
I'm assuming it would throw an error because we would be attempting to reassign an already existing key.
That's a really good guess, but actually a cool behavior of objects in JavaScript is that rather than throwing an error, this line of code would actually reassign that property. We can make the contents of this object changeable. So with each one of these lines, we're asking the question, does user2 currently contain a property called, in this first case, name? So, if it did, then we would update that property from Samuel to JSON. But we can see on the first line of this code snippet that user2 is currently an empty object. So what that means is when we ask this question, does user2 currently have a name property? The answer is no. So Samuel was totally right. We simply add a new key value pair to this object, the key being name and the value being JSON. And the same thing on the next line of code. We're asking, does user2 currently contain a property called score? The answer is no. So like Samuel said, we add a new key value pair of score with a value of 7. And same thing on this final line. User2 does not contain a property called increment. So we're able to add a new key value pair, the key being increment and the value being this function definition. And for that reason, in the end, our object will have 3 properties on it: name, score, and increment. So like Samuel said, when we call that increment method, we're successfully able to target and update this score value. So we've now seen 2 ways to create a new user object for our quiz game. The first was creating an object literal. The second was using dot notation. But there is also a third way of creating objects. And that
Could I ask a question real quick before you move on? I'm sorry. May I ask one question?
Sure, what's up?
I just wanted to know, so since you can easily reassign the value of any key just by using dot notation, is there an importance to you to declaring a new object with the const keyword as opposed to the let keyword? Is there a difference? Does it matter since you can reassign any key just by using dot notation?
Definitely. So this comes down to a matter of this concept called pass by value versus pass by reference, which we won't go into too deeply tonight. But the sort of short answer to your question is that by using the const keyword to instantiate this empty object, we can't reassign user2 to some other value. In other words, we can't reassign user2 from the value of an object to the value of like a string, because we have already declared it as a constant, as an unchangeable object. But we can do whatever we want with the contents of this object. That's going to be sort of the beauty of working with objects in JavaScript, is because this object can't be changed, because we're confident user2 will always refer to this one specific object, we can add properties to it, we can remove properties from it, we can update the data that's stored in properties, we can do all kinds of dynamic work with the data and functionality inside of the object. But the object itself will always refer to, or the label itself of user2 will always refer to a particular place in memory that's storing this object. So it will be assigned to this object.
Right. Thank you.
Yeah, for sure. Definitely an important concept, a fun one to read about. So if y'all are curious about learning more, you can look up, like I said, pass by value versus pass by reference. So thank you for that question. And for now, let us keep it moving along to this third approach here, which is going to be using Object.create, this native method called Object.create, which we can see in action here on the slide. And the first really important point about this method is that no matter what we pass into the Object.create method, it will always return to us an empty object for us to work with. And I'm so sorry, I'm so bad at drawing curly braces. You would think after drawing them for like 3 years, I would be better at it. That's about as good as it's gonna get. So Object.create will always return to us an empty object, no matter what we pass in as an argument. If we pass Object.create a primitive value, a string or a number, it will return an empty object. If we pass in another object that has 1,000 properties on it, it will return an empty object. If, as we're doing here in this code snippet, if we pass in null, it returns an empty object. So just know that the argument we pass into Object.create has absolutely nothing to do with the properties that we're later adding here using dot notation. Here we're using dot notation to add a name and a score and an increment method. So rather than having to do with that data that we're going to populate this object with, the argument we pass into Object.create has to do with the prototype. And the prototype is a concept we're going to be talking about for the rest of this workshop. So for now, just know that under the hood, Object.create will always provide us an empty object for us to start out with. So that means we can probably skip the like detailed walkthrough here. If we know that Object.create returns an empty object, that means, user3 is being assigned the value of this empty object. And on the subsequent lines, we're just repeating what happened on the last slide. We're adding a key of name and giving it a value of Eva, a score and giving it a value of 9, and an increment method storing the value of a function definition. So in a way, these 3 approaches that we've seen so far to creating objects are all ways that we can add users to our quiz game manually. Like we're using one of 3 approaches, an object literal, dot notation, or here we're using Object.create with dot notation to create each of our users, and we're sort of hard coding their related data. And if our application, our quiz game, only had 10 users, then this type of like manual hard coding approach might not be that big of a deal. But I already let you know upfront my intentions are to make a very popular quiz game. If we're going to have thousands of users or millions of users, then this approach of adding users manually is tedious. First of all, this would be tedious to code out over and over and over, but it also violates a particular principle that we always want to adhere to for clean, efficient code. Does anyone know what principle I'm talking about that should drive the way that we write code? You can just shout it out if you know.
Dry.
Dry. What does dry stand for?
Don't repeat yourself.
Repeat yourself.
Yes, don't repeat yourself. We do not want to be adhering to the wet principle. I don't know if y'all are familiar with the we enjoy typing principle. No, we want to follow the dry principle. Do not repeat yourself. If we used one of the approaches we've looked at so far, we would be copying and pasting the same code over and over again. But that simply will not do. As developers, we always have to think about scaling, about the efficiency of our application at scale. Basically, if our application totally blows up, if we've got millions of users, what could we do to create these user objects? So that's what we're going to focus on for the rest of today. We're going to talk about 4 different solutions for making our code drier and more efficient and more scalable and more dynamic. So we're going to start with solution number 1, which is going to be generating objects using a function. Now, like I mentioned, we're going to cover 4 approaches here. I'm going to ask for volunteers to help walk us through. We're going to do some diagramming. If at any point you have a question, just go ahead and use the Zoom raise hand feature. Raise your hand and I will call on you when we come to a good stopping point. But we'll start off here with this first approach, generating objects using a function. And in this approach, we're basically going to turn a regular old function, this user creator function, into kind of like a factory for functions. It's going to be for objects. It's going to be a function that works like a factory line, cranking out objects. So just to like briefly walk through here, we're about to diagram it out, but we've got this function here, user creator. It has 2 parameters, name and score. And then within this function, we're employing that second approach we just looked at, that dot notation approach. So we're instantiating an empty object called new user, and then we're using dot notation to populate it with these 3 properties of name, score, and increment, and then returning that object out at the end. And this approach is going to allow us to ultimately impact the data that's stored on our user1 object with targeted increment functionality, as we'll see. So like I said, we're going to do some diagramming here to take a closer look at what is going on. Can someone who's been to a hard parts before, I know we've got a lot of hard parts veterans in here. Can someone who's been to a hard parts workshop before walk us through how this board's going to be set up for diagramming? I've sort of laid out here the global execution context, but there's some other parts of this diagram that I would love for us to cover, just so we're all on the same page about what we're looking to track here. Do I have any volunteers to help us get set up? Yeah, Christian.
Cool. So on the right, we should have our global variables or our global values.
Absolutely. We call this,
Global
our
memory.
global memory. I forgot that I had it under that. I was just going to write it out. We call that our global memory.
And then
Absolutely.
that kind of like cup looking thing with global and the parentheses is our call stack.
Totally. Yeah, we've got our call stack down here. And then do you remember there's one other piece of this diagram we're going to use to help us track the execution of our code line by line? We kind of represent it like an arrow. Do you remember what we call this arrow?
Oh, no, actually, I'm blanking on that one.
That's all good. Oh yeah, Brandon, do you want to
Oh,
jump
the
in?
thread of execution.
Yeah, that's right. That's right.
You wrote the TH and I got it.
Execution, totally. Thank you so much for getting us set up, Christian. So we've got these kind of 4 major pieces of the diagram here. We've got the global execution context, which represents the global scope in JavaScript. It's the context in which our code's going to be executing. Here on the right-hand side, we have our global memory. This is going to keep track of all the data that's globally available in our application. And then here in the bottom left, we've got our call stack. Now, the call stack, like Christian said, the kind of like cup looking thing, the call stack helps JavaScript to keep track of what function is currently being run and in what order it's been called in our application. And you see here at the bottom, I've already added to the call stack this global execution context, which is the same one that we see outlined on the entire left side of this diagram. So all we're designating here is that all of our code, every function that's ever called in this application is going to run inside of that global execution context. So we'll always see global at the bottom of our call stack. And then that last piece, the thread of execution going forward, you may sometimes see me refer to it by the horrible acronym TOE. It's horrible, but I love it. I think it's a great acronym. The thread of execution is sort of akin to reading a book with your finger running down the page. We know, like, at least in an English language book, we read each line from left to right, and ultimately we read the page from top to bottom. And that's the exact same way that JavaScript runs, or the same way JavaScript is read. It's read from left to right, and from top to bottom. So the thread of execution is kind of like your finger on the page of a book, reading over each line. It's tracking exactly which part of our code is currently running. Now, Kristen, you've already gotten off to a great start. Do you want to go ahead and walk us through this code with your best technical communication?
Sure, I'll give it a shot. So first we on line 1 declare a function user creator. And that's just the definition function in global memory stored. So it's
Absolutely.
user creator.
Totally. We're declaring this function user creator. And for now, we're just storing its function definition here in the global memory, which just means we're not doing anything with it yet. We're just storing it so that it can be used later. What happens next?
We jump all the way to 11 because that's where I think you see the curly brackets close for user creator function. And we declare a const user1 set equal to user creator, passing in Alex and 3 as property or arguments for name and score respectively. And
Totally.
so
So we can say we're declaring this const user1, we're storing it in global memory, and we're going to assign it to the evaluated result of invoking user creator, passing in these arguments of Alex and 3. So at this point, when we invoke this function user creator, what's going to happen next? How are we going to track that execution in our diagram here?
we're going to open a local execution context and add that to our call stack.
Absolutely. Oh, dang, I thought it was going to snap too. Sometimes Notability, this application will make it into a nice pretty box, but that's good enough. Absolutely. So we open this new local execution context. So I'm going to write that here on the right. What's the right side of this local execution context going to represent?
Local memory.
Absolutely. So we've got our local execution context and we've got our local memory. And then what did you say is going to happen with the call stack?
We add this local execution context to our call stack on top of the global memory.
Push, exactly. We're going to push this function call onto the call stack. So we'll push user creator, passing in those arguments of Alex and 3 onto the call stack. And then what's going to happen to the toe?
We are going to work our way through the function user creator.
Totally. Yeah, that toe is going to get dipped right into the local execution context so that we can start to execute this code line by line. So what's going to happen inside this function?
So we declare a const new user set equal to an empty object in local memory.
Before that, there's one other thing we're going to do. The very first thing we're going to do, we invoke. Oh, you remember? You're good at like
we set name equal to Alex and score equal to 3 in local memory.
Totally. Yeah, we're going to pair up our arguments and parameters. So in this case, we've got 2 parameters, name and score. So the very first thing that's going to happen is, we'll pair those up here in local memory. So this parameter of name is going to be matched up with the argument of Alex. And this parameter of score will be matched up with the argument of 3. So what's going to happen from there?
Okay, so we're going to declare a constant new user equal to an empty object.
Yeah, and where are we going to declare that object? Oh, in local memory, exactly.
No, local memory, yeah.
So we declare this const new user in our local memory, and we assign it the value of an empty object. What's going to happen now?
On line 3, we do new user dot name, which is going to search the object new user for a name method, and it doesn't find it, so it declares name as the key, and the value name is equal to name in our local memory, which is Alex.
100%. What happens next?
We do the same with score, and since it does not find score, it sets score equal to the argument score that we passed, which is 3.
Totally. And then what?
And then we do the same with an increment, and it doesn't find it, so we add a value or a key increment and set that equal to a function definition.
Totally. So we don't find that increment property on new user, so we add a key of increment and assign it the value of this function definition. Chef's kiss, beautiful. What happens now that we've populated this object with these three properties?
Finally, return new user, and that's our cue to exit local execution context.
Yeah. And
So
where are we
it's
going to return this object to?
to user one, the constant that we declared. on line
Absolutely.
11.
We're going to return it to user one, to this label user one here in global memory. When we said we were going to assign user one to the evaluated
result,
of invoking user creator, that's exactly what we mean. The evaluated result is just whatever is ultimately returned by user creator. So absolutely right. We're going to store this under the label of user one. And now that we have made a return from this function, what's going to happen here in our diagram?
The local execution context gets what is it, garbage collected, and we pop a user creator off of our call stack.
Totally, yeah. This local execution context is closed out. It becomes eligible for garbage collection. We pop, love that terminology. We pop user creator off the call stack, and then our thread of execution basically just continues onwards, right? It's no longer inside of that local execution context, so it can just go down to the next line of code on the page. Christian, thank you so much for walking us through this first execution. I think you've done a beautiful job walking us through user one, which on line 11 here is where we're instantiating user one. But if you'll look at the next line of code where we're declaring a const user two, the logic is very similar here, right? We're declaring a const user two, which we're going to be storing in global memory, and we're assigning it to the evaluated result of invoking user creator, passing in JSON and 6. And the exact same thing is going to happen here as what Christian just beautifully walked us through with user one. So we're not going to diagram the whole thing out, but we can see that in the execution context of user creator, we'll still be declaring this const new user, and we'll be matching up those arguments passed in to the values stored in this object. So the result of calling user creator, passing in JSON and 6, is going to be an object that looks very similar to user one, right? Except with some new data. So we'll have a name of JSON. What is JSON's score? It is 6. And we will have a function definition under this key of increment. Now, Christian, I do want to throw it back over to you for a moment as we reach this last line of code here, user1.increment. Can you walk us through? We won't diagram it, but can you sort of walk us through what's going to happen when we call this line of code?
Sure. We're going to first we're gonna call on the method increment from our user one object, which is in global memory, and then we're going to go into that new local execution context inside of that called on value or property from that object. And
yeah, or even just to tackle it from a higher level, basically like our interpreter, it's exactly like you said, our interpreter is going to start line 13 and see user one. So I think you mentioned this, but where is user one stored? Where are we going to find that?
Global memory.
Yeah, here in global memories. So then this dot that's in the middle of line 13 following user one, is dot notation. We're looking to access a value inside of the user one object. So when the interpreter goes inside of user one, does it find a property called increment?
Yes.
It does, yeah, absolutely. So that means we're able to call that method. That's where we're finding that function definition. And then from there, you can just pick up sort of high level. If we find this function definition, then do we pass the test basically? Like, are we successful at incrementing this score?
Yeah, it's just going to call the function and increment score.
Yeah, 100%. We'll be able to target Alex's score of 3 and increment it to 4. Thank you so much, Christian, for finishing us off on a strong note as well. We see here that we are still achieving this running goal. We call increment on the user one object and it works. But in this case, I think we've made our logic at least somewhat more dynamic, right? We're no longer manually adding all of the pertinent information about each user one by one. Instead, we're using a function into which we can pass a name and we can pass a score, And then the function does the rest for us. The function creates this empty object, it populates it with the data that we've passed in, and it returns that object for us. So that's why earlier I sort of alluded to this function as acting almost like a factory. It creates these unique objects using the arguments that we pass in, the unique data that we are passing in. And I see your question, Christina. I'll take it right at the end of this slide because I just want to talk sort of about pros and cons of this solution. So like pros in my mind, easy to read, easy to reason about. We love that. Another pro, of course, it worked. We were able to increment the score of only one particular user. So it's looking great so far, especially because it looks to me like we're not repeating ourselves so much. Or are we? Like looking at this function definition again, it's definitely less repetitive than our previous solutions, but does anyone want to volunteer thoughts on how much of an improvement this is? Like, do y'all notice any areas of repetition in this function if we had multiple users?
Time you create a new user, it's like storing the function definition.
Absolutely. The function definition for what specifically?
For increment, the increment method.
Totally. Oh, I didn't mean to erase it dramatically, but you're absolutely right. Yeah. Every single time we run this user creator function, every time we create a new user object, we are storing this increment method over and over and over. And we know that objects containing similar data, these repeated user objects, will have a similar shape. We're expecting they're all going to have a name property and they're all going to have a score property, but they'll be assigned the value of different data depending on the arguments that we pass in. But this increment method is a little different because it's not going to change from user object to user object. It's going to be exactly the same code, no matter how many users we create. And like in this case, this increment function definition is only 3 lines of code as it's currently written here. And that might not seem like a huge deal, but as software engineers, we always have to be thinking about our applications at scale. So thinking about it that way, let's say our application has 15 million users. That's 45 million extra lines of code being stored in memory if we store these 3 lines over and over 15 million times. So why would we do that? Why store the same logic again and again and again if it's not changing? That just seems like a huge waste of space and a huge waste of resources. So as it turns out, this solution is actually not that great. It's pretty repetitive. We're likely to waste a lot of our precious memory space on repeated code, and we're looking to make the greatest quiz game of all time. So I think we're going to need to keep looking at other solutions. But before we do that, Christina, did you still have a question about this approach? Yeah, what's on your mind?
Yes, it's not a question about this approach, but more of a semantic question. When user creator, which is a function, has a method on it, which is another function, does this count as a closure, or by nature of this being object-oriented programming, we're not really calling it that?
No, closure is a separate concept. This is really a perfect display of the OOP paradigm. This is sort of by design, objects pair up data and functionality in this way. So it's not so much about protecting this functionality, or isolating it from the rest of our program. It's actually sort of the opposite concept, as we'll see. We're going to explore some different implementations, but it's a way for us to make this functionality available to many parts of our application rather than sort of sectioning it off or isolating it from the rest of our program. It's a great question, though.
Yeah, that helps. Thank you.
Of course, yeah, absolutely. All right, y'all, cool. Well, let us check out now another approach that might help us to pick to address this problem that Christina pointed out, this repetition of our increment function definition. So our second approach here is going to be to use the prototype chain. So rather than having all of those 45 million extra lines of code, 3 extra lines for each of our 15 million hypothetical users, why not just store the increment method that we know each of our user objects might need access to somewhere else, rather than storing it on each individual user object? Well, we can do that using the prototype chain. So the idea here is that if the JavaScript interpreter, the engine that's running our code, if it doesn't find the right function definition directly inside of the user1 object, it can check somewhere else in another storage place, in another shared object for that same functionality. And JavaScript gives us a built-in feature that lets us make a link to a shared object like that. What in this example, we're going to be calling our user function store, just a storage place for all the functions related to a user, so that it can automatically go looking there for functionality if it doesn't find it in our local object, which I think is so cool. What a cool concept, right? So how does JavaScript actually do that? Well, it does it using something called the prototype chain, this chain or link or bond between two objects. Now, we're going to talk a little bit later on about the built-in prototype object that JavaScript gives us. But for now, let's think about using the prototype chain to link each of our user objects with a specified shared store of user functions. So that's going to be the idea here of this second approach, using this object we're instantiating called user function store, which we can see is just another regular object that we've declared here, and we've populated with two methods. We've got these two pieces of functionality. We want to be able to increment each user's score, and we want to be able to provide some kind of, in this case, arbitrary login functionality for each user. But we have one object holding these two function definitions. So the idea here is any functionality we want all of our user objects to have access to, let's add it to this user function store in order to avoid repeating these function definitions in each and every user object. So let's get into it. We're going to do a line-by-line walkthrough here in a diagram. And I don't know why there's like little scribbles everywhere, but do I have a volunteer to walk us through this approach here line by line? Who wants to lead us through this diagram? Yeah, Julie, let's do it.
Okay, from the very beginning, like I know you have it drawn out, but do you want me to say like, oh, create your global memory execution, global execution context box, all that jazz?
Good, like we can consider the diagram set up for now, but yeah, I would love for you to start right at line 1 and kind of talk me through where we're storing all of this data and how we're going to be accessing it and all that.
Awesome. Okay, so line 1, we're going to store our function user creator in our global memory, which takes 2 parameters.
Yeah, so we're declaring this new function user creator, and we're going to store its function definition here in our global memory. Absolutely. What's going to happen next?
Next, on line 8, we're going to have our const variable labeled user function store assigned to an object.
Yeah, so where are we going to store this user function?
That is also going in global memory. Forgot to add that bit.
Absolutely. I'm just going to abbreviate it if you don't mind to UFS. This is our user function store. And what's the value of UFS going to be, of our user function store?
Curly brackets.
Totally. Yeah, it's going to be, we're going to assign it the value of an object, right?
Value of an object.
What's living inside of this object?
We have 2 key value pairs, 1 key increment with a function definition. And then we also have the key login with another function definition.
Absolutely. So we've got this user function store in our global memory. We've assigned it the value of an object literal, and we've populated it with these 2 methods, increment and login. And like Julie said, each of those is storing its own function definition. So Julie, what's going to happen next?
Next, we have on line 13 another const variable, user1 declared. Goes in global memory.
Yeah, totally. So we're declaring this const user1 and storing it in global memory. And what's the value of user1?
User creator invoking some lovely arguments.
Yeah, absolutely. We're going to assign user1 the value of the evaluated result of invoking user creator, passing in Alex and 3. So that's just kind of a fancy way of saying we're waiting for this function to execute before we know what the value of user1 is going to be. So I'll just write it down here for everyone. This is definitely a key and helpful, I was going to write evaluated helpful, evaluated result. This is definitely a key technical communication phrase to keep in mind. So we're declaring this const user1 and we're assigning it to the evaluated result of invoking user creator, passing in, what did you call them? These beautiful arguments.
Arguments, yeah, beautiful arguments.
So what's going to happen at this point? We call user creator. So how are we going to track that here in our diagram?
So now we go to our global execution context and we open up the thread of execution using line 13's information. And it's going to invoke the user creator function up on line 1.
Totally. So yeah, a few different things are going to happen here. We're going to open up this local execution context, which we'll represent here. And Julie, can you remind me, what are the two halves of this local execution context going to be?
It's going to have a local memory and the local execution context.
Absolutely. We have our LEC, our local execution context, as well as our local memory 100%. And then what's going to happen to our call stack?
Our call stack is going to push user creator.
Totally. Yeah, we're going to push
that's what we're
user
using.
creator here onto the call stack 100% with these arguments of Alex and 3. So that's been pushed onto the call stack. And one thing that's just not written here on our diagram yet, do you remember what we call this, this sort of like finger on the page reading over our code line by line?
The toe.
The toe. Yeah, I was going to write it out, but let's just call it the toe, the thread of execution. Absolutely. So we've got the toe, we've got our local execution context, and we've got our call stack tracking the execution of these functions. So now that we're inside of this local execution context, what's the very first thing that's going to happen?
We're going to add some information to the local memory with the name and score.
Yeah, absolutely. We're going to pair up our arguments and
pair our argument and parameters. So the name is going to be assigned to Alex in the local memory, and the score is going to be assigned to 3.
100%. So we pair our arguments and parameters. Name has a value of Alex. Score has a value of 3. And what's going to happen next?
Now we can work our way through the user creator function. So this would bring us to line number 2. And we have our variable new user, which will, oh my goodness, is that going to local memory? It's going to local memory because we haven't invoked anything there. So new user is on local memory, and it's gonna Object.create. It's gonna create an object.
Totally. Yeah. Do you remember whatever we pass into Object.create? Do you remember what it returns to us?
An object.
An object, yeah, it just gives us a nice empty object to work with. And you're totally right. It's going to live here in our local memory. So we run line 2, we declare this const user creator, we assign it the value of an empty object. What's going to happen on the next line?
I'm not going to be able to technically tell you this beautifully, but I will tell you it as best as I can. So we're going to go to line 3. No, we're invoking user function store. So now do we hop to line 8?
So we'll actually circle back around to that user function store. You're totally right on right now that Object.create is going to give us an empty object. And we'll talk about what we're doing with user function store there. But whatever we pass in here, if we passed in a string here of Julie, or if we passed in null, anything we pass in here, Object.create is going to give us back an empty object. So we can just work with that empty object for now. So you were totally right that we'll move on to line 3. So what's going to happen on line 3?
So then this information is going to be in the LEC, I believe, and it's basically pointing to the information that we need. It's letting me know that Alex is the name, and then onto line 4, it's letting me know like number 3 is the score. Not as technically communicating, but I just know that it's pointing to this, trying to show me where it's at.
Yeah, you're totally right. So like here on line 3, do you remember we said this bit of code here that I just underlined is kind of like asking a question? Do you remember what that question is when we use dot notation like this?
Where can we find this?
Yeah, where can we find this? Like in this case, like where is new user living?
New user is living, where is new user? It doesn't have anything yet, but it's an object. It's in the local memory.
Totally, yeah. So new users living in local memory, and by using dot notation here, basically the question we're asking is, does the new user object have a property called name? Which does it right now?
No.
Exactly, it doesn't. So exactly like you said, that allows us to add a new key value pair to this new user object with a key of name, right? We're indicating new user dot name. So that's the key. And we're passing in a value, like you said, of Alex. We're grabbing that name value from our local memory. So we add this key value pair here of name and Alex. And then the same thing will happen on the next line. Exactly like you said, we're going to find this new user object in our local memory. And then using dot notation here, we're basically asking the question, does new user currently have a score property? And does it?
No.
No, exactly. So we can add another new key value pair here, a key of score and a value of 3, which we also find in our local memory. That's that data that was passed in when we called this function. And then what's going to happen on the next line of code?
Now we can return new user.
Yeah, 100%. And where are we going to return it to?
We're going to return it to the global memory, and it's going to be stored under user 1.
Yes, absolutely. We're going to return it to global memory under this label of user 1, which we've just been waiting for this result to come back, right? We said we're assigning user 1 the evaluated result of invoking user creator, and this is the evaluated result. It's whatever's ultimately returned from this function. And can you remind us, how are we going to clean up our diagram here now that we've made a return from this function?
We need to pop off the user creator and call stack, if that's what you mean.
Totally, yeah. We'll pop user creator off the call stack. We'll close out this local execution.
Oh, and then close out the local execution.
Absolutely. It will become eligible for garbage collection, and our toe will just go on its merry way. The toe's going to have a great night going on reading the rest of our code. Julie, thank you so much for walking us through the integration of user creator. And exactly like Julie mentioned, one other super important thing is happening under the hood here. So when we employ Object.create on line 2, in addition to creating an empty object, we saw it returns as an empty object. We can then populate it with data. Under the hood, we are also instantiating, we're creating a link or a chain to some functionality that lives elsewhere. So in this case, when we used Object.create, we passed in user function store. So a couple of things are happening. We get that empty object that we populate with dot notation, but additionally and simultaneously, Object.create is also creating this link between our newly created new user object and the user function store, that object that we passed into Object.create when we called it. So this link is going to allow us to create this bond. It's what's going to allow a user object to access functionality that's living on another object. So this object here with our custom properties here, this data of name and score, has a link, a chain to this user function store object containing some functionality. Cool. Is everyone following so far? We've got this object populated with data like Julie walked us through. And because we've passed in user function store to Object.create, our object is linked to the functionality living in that object. Cool. Yeah, John.
Yeah, I had a question. So about how that's actually happening under the hood. So is the increment and login properties of user function store being assigned as prototype values, as prototypes to a new user? Like how is the new user constant, that variable, able to access increment and login later?
Yeah, under the hood, Object.create is designating user function store as the prototype object. So it's this storage place of some functionality that JavaScript understands is the prototype object of new user under the hood. So we're going to kind of look at how that access to the user function store functionality happens. So we're not yet using the built-in prototype property that JavaScript gives us, but we are using sort of like lowercase p prototype here. We're designating that the user function store is the prototype for our user 1 object, or for our new user object.
Okay, I see. All right, thank you.
Cool. Yeah, for sure. Awesome. So now that we've done this, Julie gave us this beautiful walkthrough of our user 1 instantiation. The same thing's going to happen with with user 2. So I'll sort of draw out what the result of it is without going through the full step-by-step diagram. So on line 14, we're declaring this const. It's a color I haven't used yet. Maybe, nope, I used that orange. So we're declaring this const user2, which will be stored here in our global memory. And we are assigning it to the evaluated result of invoking user creator, passing in JSON and 6. So if we were going to diagram this out, we'd open up our local execution context, we'd push user creator onto the call stack, and our toe would weave into this execution context. So, if we were to diagram it out, we would once again see Object.create return an empty object to us that we can populate with dot notation. And just like with user 1, because we again used Object.create, we know that this new object will be linked to our user function store, this argument that we're passing into to Object.create. So that tells us, if we diagram out here what the result of line 14 is going to be, the evaluated result of calling user creator is going to be this object that looks a whole lot like user 1, but in this case, its name will be JSON, right? The argument that we've passed in here. Its score will be 6. And this object as well will have its own link to the user function store. In both cases, these user objects are being created using the Object.create method, which gives us an empty object that is linked to the object we're passing in as an argument. So we've now reached this final line of code. Julie, oh, you just moved on my screen, but you're still here. Do you want to volunteer to keep walking us through, or do you want to phone a friend to finish this off?
I don't mind going through.
Amazing, let's do it. So can you pick us up at line 15? How is JavaScript going to try and find this function definition?
User1.increment. So on line 15, it's invoking the increment function, which is over on line 9.
Yeah, so
Wait, how are we even getting there? Oh, we have user 1 information, which is in global memory, and it's going to look for the increment. Can I just go in there though? Because it says user function store on line 8. Wouldn't I have to do user function store dot increment? Or am I allowed to just jump? You know what? Education opportunity.
Yes, education opportunity, growth opportunity. Samuel, do you have a question, or are you jumping in to help? If it's a question, I'll hold it for now. Question?
It was a question, yeah.
Cool. All right, we can we'll hit pause on it for now just to finish this out. So yeah, Julie, you're totally right that the interpreter, which is reading our code from left to right, is first going to see user 1 and be like, what is user 1? And it's going to check the global memory. And is it going to find user 1 in our global memory?
Yes.
Yes, it is. Absolutely. So then we see this dot notation here on line 15, which indicates we're trying to go into user 1 to find a property called increment. And if we look at user 1 here in global memory, do we find this property called increment?
No.
No, we do not find a property called increment. So here we're going to see this very cool behavior. JavaScript looks in this user1 object and doesn't find increment, but rather than assuming that there's an error, it sees this hidden chain here from our user1 object, and it follows this chain. It investigates and says, let me check out all the prototypes of this user1 object to see if any of them might have an increment method. So it follows up this prototype chain here to, in this case, the user function store. And Julie, if it checks user function store for the increment method, does it find it?
Yes, it does.
It does. Yeah, absolutely. So does that sort of answer your question about how we're using dot notation the same way as always? It's just that JavaScript's not finding the function definition inside of user1, but it's following this hidden chain and it finds the function definition there in that user function store.
Gotcha.
So we find this increment function definition, hooray. So we've got the instructions here that we're trying to execute. So what's going to happen now as we call this increment method?
Now it can go into the user function store function definition, and then it can look at the increment value. So it can see the function, the score increment. So it will do just that. It'll increment the score. That was
Yeah,
not technically
just to-
communicated.
No, totally. You're doing great. And just to kind of like walk through it step by step, like we'll open up a new local execution context, which is going to be split into our local
LEC
execution
and
context.
LM.
Absolutely. LEC, our LM is our local memory. And then we're gonna, what's gonna happen to the call stack?
The call stack is gonna push in user1.increment.
Absolutely. We'll push user1.increment onto the call stack. The toe will weave its way into this local execution context. And just looking at the function definition for increment, what are we trying to do here? What are the instructions telling us to do?
We get to use the value of increment. So it's going to allow us to increment the score of user1.
Yeah, so what increment is telling us to do is execute this logic here of this dot score with the increment operator. So let's take a pause here. Yeah, because the this keyword is kind of confusing. Let's break this down. And the this keyword is always a little hard to talk about. You just realize how many times you use the word this in conversation. The this keyword refers to an object. It refers to a particular object at any given time. And which particular object it's referring to depends on the way it's being used. But the sort of short definition is that this refers to the object context in which the current function is executing. And there are a number of different rules that tell us the value of the this keyword in any given context. So for instance, if you have a function being called on an object, which is exactly what's happening in this particular case, we have a function increment being called on an object, being called here on user1. The value of this is just whatever's to the left of this dot. So we're calling increment on the user1 object. So that's just a built-in rule for the this keyword. Whatever's to the left of that dot tells us the context, tells us the function that the method is being run in. So knowing all of that, Julie, in what context is increment being run in here?
Increment is being run to look at the user1 score, which is located in global memory, and the score is listed as 3. So we're going to increment 3.
Yeah, just rewinding a little bit though, just the very first thing you said is increments being run in the context of user1. So the value of the this keyword being whatever's to the left of the dot here is just going to be user1, which we can store here in our local memory. This is referring to the user1 object because on line 15, we're calling increment on that user1 object. So Julie, do you see user1 in our local memory? Do you see that whole object in our local memory?
No.
What about in our global memory?
Yes.
Yeah, absolutely. We find it in our global memory. So I have stolen your thunder many times. What's going to happen now? We found this user1 object. We know that we want to increment that score property. What is the final result going to be?
So now we go to line 14. I'm just kidding. So now we increment the score from user1 3 to 4.
Yes, 100%. We are going to grab that score property. We're going to increment it from 3 to 4, and then we are going to see our diagram sort of cleaned up here, right? Now that we have executed this functionality, our local execution context will be closed out. Our thread of execution will continue on to the subsequent code as user1.increment is popped off of the call stack. So the idea here, a huge round of applause for Julie, absolutely crushing it. Love that you leaned into that learning opportunity. You knocked it out of the park. The idea here is that we've done a lot to eliminate this whole issue we've been facing of repetitive code. And we did that by storing methods that we want all of our users to be able to access in one centralized location. So by being stored in this one central location, any of our users that want access to whatever is inside of the user function store have that access. And the reason they can access it is because we used Object.create to create a link from any of our user objects to that main user function store. So that's the main point of this approach and of this diagram. We are going to build off this going forward, but Samuel, you've been so patient. What's your question?
My question was the chain, the link from, like, for instance, our user one object, user two object to their prototype, the user function store. Is that what's referred to as the Dunder proto?
We're going to talk about the Dunder proto a little bit later on, but the Dunder proto does refer to the prototype of any particular object, to sort of the whatever object is next up in the prototype chain of an object.
Right. So then would also user function store have its own prototype, being the object prototype?
Yeah, user function store. So at the end of the very end of the prototype chain is going to be null. You know you've reached the end
Null.
of the prototype chain when you find null, but one level down from that is going to be that built-in object.prototype containing some methods JavaScript gives us to use in conjunction with objects. Absolutely. So as we work our way up the prototype chain, that final object is the built-in object.prototype. And the prototype of object.prototype is null. That's how you know you've reached the end of the chain.
Thank you.
For sure. John, what's up?
I had a similar question to Samuel's about that prototype chain that we're creating. So for our argument in Object.create, in this case, it's user function store. Do we have access to whatever that argument is, like that type prototypes? So like user function store is an object, so it has access to the object prototype. So if we passed in a string, would we be able to access string prototype methods as well?
Yes, that's like an additional layer of complexity we're not going to get into tonight, but like sort of in a similar vein, if we passed in null, then we would just end that prototype chain right there, and we would sort of limit the access that a particular object has to subsequent object prototypes. So you can use the argument you passed into Object.create to control what your new object has access to.
Okay, so to confirm my understanding, like in line 2, when we declare the constant new user and assign it to Object.create, and let's say we pass in a string, would new user like suddenly be able to access like string prototype methods or array or whatever you put in?
Yeah, so I mean, if we pass in exactly, you can control the prototype methods that are available to this object you create by designating the data type of the object of the argument that you're passing into Object.create. So yes.
Okay, gotcha. Thank you.
Cool. Yeah, absolutely. All right, y'all. So let us keep it moving. Oh no, my keyboard died. There it goes. We're reconnected. So this is still solution 2 that we just covered. We're still using the prototype chain. This I think is actually a pretty good solution to our problem. Do y'all agree with that? Pretty good solution. We just saw before, now we're just storing this one line of code, this increment function definition that all the other users can just reference. So we don't need to store this piece of code again and again and again. So we used the object class and its create method, passing in an argument, the object that we wanted to create a link to. We created a prototype where we had just this one line of code being repeated. And if you're still confused by this concept of a prototype, just like high level, prototypes are just the ways that objects in JavaScript inherit features from one another, the ways that one object inherits features from another object. So we created a prototype, and then all we had to do was use the this keyword to make the context of the function dynamic. So by the way that we're using the this keyword here, JavaScript knows which name we're referring to, and it knows which score we're referring to for any given user input. So does everyone see how this addressed our problem, how we created this shared store of functionality that we could access from our user objects? Yeah, cool. Awesome. Well, this is a great solution, but let's see if we can still optimize this code a little bit further. So what if now we introduce a new keyword? And what if, in fact, this new keyword is the one and only new keyword? This solution is going to throw a new tool in our tool belt, the new keyword. And the new keyword is fantastic. It's going to abstract away from us a lot of these processes that we've just seen in action, that we've just painstakingly diagrammed out. And it's basically going to do a whole bunch of stuff for us under the hood, meaning we won't necessarily have to do those things in the code that we are writing anymore. And just as a reminder, no matter what technique we use, no matter how we apply it, the OOP paradigm remains the same. Henry, can you remind us, like, what's the main rule or the main kind of idea behind object-oriented programming?
It's linking data and functionality.
Woo-woo, yeah, absolutely. Data and functionality are encapsulated side by side. So in the case of using the new keyword, we can just think of what the new keyword does in like sort of, terms that linguistically just like make sense to us as humans. It's a very semantically named keyword. Like, what if we make every new user in our quiz game a new instance of user creator? Like when we create user 1, let's make it a new instance of user creator. And when we create user 2, let's make it a new instance of user creator. I love a semantically named keyword like this. So how do we actually do this programmatically? Look at all of this stuff from our previous example that is crossed out now, that we just do not need anymore in this new approach, because the new keyword is going to abstract it all away from us. So we no longer need to code all of these steps out, creating the empty object and populating it, with dot notation and returning it. But all of those steps are still happening under the hood. And in this case, we can see that this keyword we were just talking about is doing a lot of dynamic work for us. So how does this actually work? Before we move into diagramming this sort of third approach here using the new keyword, I just want to do a little interlude. And I want to make the point that functions in JavaScript are both objects and functions depending on how we work with them. So we can actually affect a function in JavaScript as a function, or we can affect it as an object. So what this means is that we can use this fact. We can use the fact that all functions have a default property on their object version called prototype, which is itself an object, to replace that user function store we just diagrammed out in our last example. So instead of using that user function store, that designated object full of function definitions, why don't we instead use this built-in prototype object within the object form of our function? If we do things this way, there's no longer a need for us to declare a whole separate object and to fill it with the functions that we want each of our user objects to have access to. So let's see what that means in practice. Just a very simple example to show you what I mean. Just to save us some time, since I know we don't have too much left, I'll kind of quickly walk us through the major points here myself in terms of the diagram. So we are declaring a function definition here on the first line called multiply by 2, multiply by 2. And we can see that, we're storing a function definition, right? So I'll represent that the way that we have been representing it as a function definition. But I mentioned that multiply by 2 has two forms. It has this function form, which we're used to, this function definition, but it also has its second form, an object form with maybe some built-in properties on it. So this is how I'll represent that object form, literally taking all of my attention and focus to make those curly braces. So we'll represent it sort of below this dotted line. We've got our function definition up top, and below that are the object form of multiply by 2. And when we deal with a function as an object, using dot notation, we can affect the properties stored on it just like we'd affect the properties on any object. So it has some built-in properties, actually, like, for example, name. The object form of every function in JavaScript has a name property that refers to the label of the function. So this name would be multiply by 2, totally separate from the name data we've been passing in. And it has a property called length, which is going to correspond to the number of parameters this function definition has. So in this case, 1, right? It just has this one parameter of num. And then it also has this property we've been talking about called prototype. And prototype is going to default to the value of an empty object. It's an object within an object, and it is provided to us automatically by JavaScript. We do not need to declare this object anywhere. It is automatically available to us on the object form of every function in JavaScript. So we see here in global memory our multiply by 2 function represented in both its function and its object forms. So if we move on to line 5 here, can I get a volunteer to talk us through what's happening here on lines 5 and 6? What are we doing on line 5?
On line 5, are we checking the object form of multiply by 2 for a property called stored?
Absolutely. And do we find it? From what we can see here, do we find it?
Yes.
We find a stored property? Just checking out this object form here, we've got some
Oh,
like built-in
Sorry,
properties.
over in the global memory, no, it's not
Exactly.
written.
Yeah, here in the global memory.
Yeah, no, in the global memory, no, it doesn't appear to be stored.
Yeah, I agree. So what's going to happen if this object form doesn't have a property called stored right now?
So then we are going to create that property and assign it the value of the number 5.
100%. So we're just going to add a new key value pair here where the key is stored and the value is the number 5. And then on this next line of code, we're not going to diagram it out, but basically what we're looking to show here on line 6 is that, on line 5, like Samuel just told us, we added a new key value pair to this object form. Like we have changed the contents of the object form of multiply by 2. So on line 6, then we call the function definition of multiply by 2, which is, up here at the top of the function. If we pass in an argument of 3, we'd expect, 3 times 2 to equal 6. We'd expect to get 6 back, and we do indeed get that. So the idea here is, even though we on line 5 treated multiply by 2 like an object, and we added a new key value pair to it, that didn't break the function definition. It didn't, negatively impact multiply by 2. That object form can contain all kinds of data. We can store whatever data we want in there, and we can still use that function definition effectively. So on line 5, we store that 5 inside of the object form of multiply by 2. On line 6, we demonstrate that we can still use that function definition. And then on lines 8 and 9, Samuel, can you just walk us through, if we assume that these are our console logs, both lines 8 and 9, what are we going to see logged, or where are we going to find these pieces of data?
Okay, well, in line 8, we would be checking for the stored property on the object form of multiply by 2. And if we logged that, we would get the value 5 to print in the console.
Absolutely. We check that object form for a key of stored, and we find it, and its value is 5. So we would console log that 5. Absolutely right. What's going to happen on line 9?
On line 9, we're again going to check the object form of multiply by 2, but we're going to look at it into its prototype property. And if we were to log that multiply by 2 dot prototype, it would print an empty object in the console.
100%. We're going to do the exact same thing here. We're going to look at the object form of multiply by 2. We're going to check that prototype property, and its value is going to be an empty object. And if you're wondering why the prototype object is empty, despite the fact that we've added some data, well, it's because, as Samuel just walked us through, we've stored that information. That was an unfortunate choice of words. We have added the key of stored directly onto the multiply by 2 object, not onto the multiply by 2 prototype object. Remembering that the object form has some of these built-in properties, a name and a length, and this built-in prototype object. So Samuel, can you take a guess if we had wanted on line 5 to store this piece of data inside of that prototype object? What is the syntax we would have used to access that object and store the 5 in there?
The syntax we would have used to store the 5 in our prototype would have to be multiply by 2 dot prototype. It would have to be another dot, wouldn't it, in order to go inside that object? Otherwise, it would change what prototype was into the number 5.
Yeah, 100%. You're totally right. So multiply by 2 dot prototype dot.
Would we have to create another property name in order to assign the 5 value to it?
Well, what do we want to call that key? What do we want to call that property?
Oh, stored. Perhaps. Okay, so multiply by 2 dot prototype dot stored equals 5.
100%. If we want to use this object, which JavaScript gives to us as a storage place, if we want to use that prototype object to store data inside of it, this is really all that's missing. We just need to add this additional set of dot notation to go into the prototype object on our multiply by 2 object. And from there, like Samuel said, the syntax is the same syntax we've been using all night to add a key value pair, right? We're just asking the question, does this prototype object currently have a key of stored? It does not. So we're simply using dot notation to add this new key of stored and assigning it a value of 5. But in this case, so this is a hypothetical. This is how we would have stored this data on the prototype object, but that's not what we did, right? All we did was store it on multiply by 2 dot stored directly on the object form of multiply by 2. So the idea now is rather than using, as we did in our last case, using that user function store object to store various pieces of functionality, maybe instead we can just use this built-in prototype object, this designated empty object on the multiply by 2 object form and populate that instead. So we're going to run back through this code from earlier and see how this works in action. So we're going to take a look now again at solution number 3. So, this is where we were right before that interlude. We wanted to see in a little more detail where that prototype property lives and what it is, and remind ourselves what it means when we say that functions in JavaScript are objects. So let's look in more detail now at how the new keyword works and what it actually automates for us. So this is going to be our last major code walkthrough of the evening. Do I have a volunteer out there to walk us through this code line by line?
Sure, yep. So line 1 in global memory, we're going to create the key user creator, which is going to have stored a function definition.
Yeah, so we're going to declare this new function user creator, which we'll store here in global memory as a function definition. Absolutely. What is actually, let me represent this slightly differently here. Rather than simply representing that function definition, I want to do this the same way we just did with our multiply by 2 function. So I'm going to represent it as both its function form, that function definition Ryan just mentioned, and also its object form. And do you remember, Ryan, what's the name of that built-in object that JavaScript gives us on this object form?
That'll be the prototype.
Absolutely, that's the prototype. We don't need to do anything special to declare this object. It is automatically available to us, and its initial value is an empty. Wow, that's my worst curly brace of the night. It is an empty object. Cool. So now we've got this diagram set up. We have user creator here stored in global memory, and we're representing both its function definition as well as its object form containing this automatic property of prototype, the value of an empty object. So what's going to happen next, Ryan?
Sure. So then down on line 6, it's going to take the user creator object, find the prototype, and in the prototype, it's going to look for increment. It won't find any property there named increment, so it will create a new one, and it will assign that to a new function, which is another object. And yeah, that's what that'll do.
Yeah, totally. So we'll just keep it sort of like high level for now, and we'll just simply store that function definition for increment. Totally right.
Okay.
What's going to happen next?
Sure. Then go down to line 9. It's going to, again, look at user creator, find it, find the prototype of it. And in the prototype, it's going to look for login. It's not going to find it, and it's going to create another function definition for the key login.
Absolutely. It's going to add another key value pair with a key of login and a value of that function definition. So we can see here that we're now populating this prototype object with various function definitions. So we can use this prototype as our object for holding all of that functionality. This again is going to allow us to serve that #1 purpose of OOP, which is that data and functionality can coexist side by side. So what's going to happen next, Ryan?
Sure. So then it's going to go down to line 13. It's going to create a constant value key called user1 in global memory.
Absolutely. And what's the value of user1 going to be?
It's going to be whatever the function user creator returns.
Absolutely. We're going to assign it to a new instance of user creator, to the evaluated result of invoking user creator, passing in the arguments of Eva and 9. So basically what we're saying is from this constructor, from this object model, we're building a new object with some unique features, with the unique data that we're passing in here as arguments. So Ryan, what's going to happen here at this point that we're invoking user creator?
It's going to open a new execution context,
Absolutely.
as well as put the function user creator on the call stack.
Totally. And what is the final step? Missing from our diagram.
The arguments passed into user creator. So name is going to be assigned in local memory. Name is going to be assigned to the string Ava, and the score is going to be assigned to the value 9.
Absolutely. So that thread of execution will kind of like weave in here to this local execution context, and then we'll match up those arguments and parameters. Totally. So we'll match up the parameter of name with the argument passed in. So that's the string Eva, and we'll match up the parameter of score to the passed in data of the number 9. Now, what's going to happen next?
So within user creator, it's going to look at this, which, well, the first line is going to be this dot name equals name. It's going to look at that, and I'm trying to think of what this refers to currently.
That's kind of a weird one, right? And I'll just pause you right there if that's okay. I'm sorry to interrupt, but we're encountering this keyword again, and I know it's really tricky. It's often a source of confusion in JavaScript, and we're not going to go like too far down this rabbit hole, but for our purposes tonight, there's a couple of things to note. One being that this keyword defaults to the context it's being run in. So in the default case, that is the global execution context, the global scope. And that's not what we want. We're not trying to work with this big global object. We know that we never want to be polluting our global namespace with variables like name and score in this case. We want the name and score to be locally scoped to a particular user object. So that brings me to this other cool takeaway here about this keyword being used in this context, because our wonderful new friend, the new keyword, really saves the day for us. It really automates some difficult behavior, because one of the new keyword's many under the hood activities is to reassign the value of this keyword to the value of an empty object. And it does that for us automatically, like the other behaviors we've discussed so far. So here in a local memory, we're going to represent that by literally storing this as the value of an empty object. And again, this is automated for us by the new keyword, by the way that we call user creator here on line 13, using the new keyword in this local execution context. This will be assigned the value of an empty object. So knowing that, Ryan, we have this empty object now. What is going to happen to these properties inside of user creator?
Sure. So that new object, this is going to look for name. It's not going to find it. It will create a new key whose value is going to be the value of the local memory variable name.
Absolutely. So we're going to check this object, the object referred to as this, for that key of name, and we don't find it. So we'll add it here. And as its value, like Ryan said, we're going to check local memory for the piece of data referred to as name. And in this context, it is Eva. And what's going to happen on the next line?
Pretty much the same thing. It's going to look for score on this object. It's not going to find it. And so it'll create a new one with the value of local memory values score.
Which is?
9.
9. Yeah, absolutely. So we have now populated this object with the name of Eva and the score of 9, both of those pieces of data coming from the local memory. And the new keyword is also going to do one final fantastic thing, which is that it's automatically going to return. Whoops, I did not mean to delete that. It is automatically going to return this new object out for us. So Ryan, thank you so much for that walkthrough. Just to sort of recap it and to add a bit, the new keyword is super nifty. It takes care of a lot of things for us, including, like we just talked about, reassigning the this keyword to the value of an empty object in our local memory. And that's the step that allowed us to copy over all of these properties from our constructor function to our new object, right? To take these arguments we passed in, Eva and 9, and assign them values inside of the this object in our local memory. And then it also returned out this new object for us automatically at the end. And Ryan, just to close the loop, where is this object going to be returned to when it's returned from user creator?
The constant value user1.
Absolutely. It's going to be returned to our global memory where it will be stored under this user1 label. And while I fill that out, Ryan, what is going to happen here in our diagram? How are we going to clean this diagram up?
Sure. So user creator is going to get go off the call stack.
Absolutely. We'll pop it off the call stack.
The execution context is going to close out.
Totally.
And the thread of execution is going to go back to global memory. So just continue on down.
Yeah, absolutely. Thank you so much for getting us cleaned up there. Now, one detail that we haven't talked about here is one of the other awesome things the new keyword does for us, which is that it creates a link. And we've already seen that link created in our previous example. But what the new keyword is going to do is it creates a link between our newly created object, user1, and the prototype object, the prototype property of the object from our constructor function, which is in this case, user creator, right? We are creating a new instance of user creator. So the new keyword automatically creates this link between our new user1 object and that prototype object stored on user creator. And it's that bond, it's that link that allows any methods on that prototype object to be accessible or to be referenced by any of our newly created user objects. So this is data and functionality side by side. This is the whole game of OOP right here. Our user1 object is able to access these hidden methods using the specific unique data for the user1 object. So that's the whole idea here, for us to be able to accrue our 15 million users and have all of those user objects be able to access the same methods without needing to repeat ourselves over and over and over. So on the final line of code here, when we go to call user1.increment, the JavaScript interpreter first is going to find user1 in our global memory, right? And we find user1 here in our global memory. And then using dot notation here, we're saying that we want to find the increment method on user1. So the interpreter looks inside the user1 object. It does not find a property called user1, but it knows to automatically start working its way up the prototype chain. So it checks this very first prototype that it encounters. And what do you know? It finds increment right here on this prototype object. It finds those instructions that it's looking for. And we've already reviewed one of the basic rules of this keyword, which is that its context defaults to the object on which it's called, right? To whatever's to the left of the dot, basically. So we can see here from line 15 that the context for this will default to user1, which means that we are able to successfully increment this score property from 9 to 10, because we're calling that increment method in the context of user1. So JavaScript knows we're referring to the score property of that user1 object. So what this means is that, hooray, we have yet again passed the test of successfully linking specific user data and shared functionality, which is pretty cool stuff, right? I think it's super cool what this keyword does for us. And, you know, I think that this approach is a lot better than even our second approach, which was an improvement on the first. Like with the new keyword, we were able to automate a whole lot of things that we would otherwise need to do manually. So in terms of benefits, it was faster for us to write this approach. And I think it's pretty straightforward for us to understand, right? We're saying, let's create a new instance of this particular object of user creator. So it's just sort of easy to reason about in that sense. And again, it just automates so much work for us. It reassigns the value of this keyword to an empty object. And as we saw within that empty object, we were able to then populate it with properties like name and score, right? So in that way, every new instance of the object has those properties that we can make unique to that specific object instance. So that was one thing the new keyword automated for us, right? It automatically provided the this keyword with the value of an empty object. And at the same time, it also creates a link that points to the prototype property of the object form of our constructor function user creator. So whatever we store in that prototype object, in this case, we stored increments function definition there, we stored logins function definition there. Whatever we store in that prototype object is then accessible to all of the users that are trying to reference it. And then just for good measure, the new keyword also automatically returns out that newly created object for us. So it gives us this empty object stored under the this keyword, which we can populate. It links it to this storage place full of functionality, this prototype object, and then it returns that new object for us. So it does so many things for us under the hood. All in all, how are we feeling about approach number 3? It's much better, right? This is a cool approach. I think this is a big improvement over approach number 2. I love the new keyword. And we're going to talk about just one other approach this evening. The last thing that I want to show you, we're not going to diagram this one out. This is the beloved, sometimes be-feared class syntax. And it is, as it says here on the slide, it is syntactic sugar. And if you're not familiar with that expression, syntactic sugar is syntax that's designed to make things easier to read or easier to express. It's sugar because it's like sweeter for human consumption, generally without adding any additional functionality. Being syntactic sugar means it's really more of an aesthetic improvement to the way that we're expressing some logic. And I want to emphasize up front that class syntax is, in the purest sense of the phrase, syntactic sugar. So part of what that means and what I want you to take away from that is that you do not have to use class syntax in your own code. You should always go with what makes the most sense to you personally. Now, personally, for me, I love class syntax. I've got like a bit of a sweet tooth for this particular syntactic sugar, but I didn't always feel that way. And you might not end up feeling that way, which is totally fine. There's not right or wrong answers. There's many different approaches to different problems and pieces of logic that we're looking to implement. And I think you especially might not feel that way right now because class syntax just takes time and patience, and it's much better understood when your foundations in OOP and your understanding of the prototype chain are strong. So we're going to cover it more briefly than the other approaches by doing this sort of side-by-side comparison of approach number 3 on the left-hand side, which I don't want to speak for all of you, but the faces I could see, you seemed to like approach number 3. So that's on the left with approach number 4 here on the right-hand side. So on the left is our approach using the new keyword, and on the right, our newest pal class syntax. Now, the idea of the structure of this slide is probably pretty self-explanatory, but basically the two snippets of code that are boxed on the left-hand side are become the two snippets of code boxed on the right when we use the class keyword. So the code on the left here is familiar to you at this point, but the code on the right, while it might look new and different, is functionally doing the exact same thing as the code that we just walked through, which is here on the left-hand side. So we have here, looking at the right-hand side, we have the class keyword here. And then we have user creator capitalized, which is just a convention and a best practice when we're dealing with classes in JavaScript. So we're declaring this class user creator. And then within this class, we're defining, first of all, a constructor function using another keyword. We're using now a keyword called constructor. And we can see that the logic of this constructor is exactly the same as the logic in our user creator function on the left-hand side. So basically, we're using this constructor to deal with all of the data that we want to add to the object. And then any of the methods that we want to be provided to this object are going to be placed outside of that constructor function. And when the browser reads your code, when it interprets your JavaScript, it knows to add any of those methods into your prototype object, just like we did manually on the left-hand side. So we're using the constructor to deal with data. We've got this name parameter and this score parameter. And when we instantiate a new user creator, name is still going to be paired with Eva, and score is still going to be paired with 9. Again, functionally, the exact same thing is happening here. So those parameters and arguments are paired. And when this code runs, both increment and login, those function definitions will be stored on the prototype object for us, where they can be accessed by our user objects. So exactly the same thing as we designate manually on the left-hand side when, like Ryan walked us through, was it Ryan or maybe Samuel? I think Samuel, we had to use that double dot notation to add to user creator dot prototype dot increment. Now we can simply pass in, we can just declare this method increment, and by using this class syntax, it will automatically be populated on that prototype object. So with this class-based syntax, we are getting literally all of the same functionality, no more and no less essentially, but in a much neater package. It's neater maybe the more comfortable you are with it, even if right now it's a bit unfamiliar. So in the future, as you keep practicing these skills, I suspect that a lot of you will get more familiar, more comfortable with class syntax, and it will stand directly on the shoulders of all of your other OOP knowledge. So just remember, the name of the game is practice. Like, this stuff is not easy. This is called JavaScript, the hard parts. This is some of the hard stuff of JavaScript. It's not always intuitive, but I promise that you'll get to a point of great comfort and great fluency with your own preferred syntax. So just keep practicing. And so many of you mentioned at the start tonight that you love reading the docs, which I love to hear. It does my heart good. So dig into the docs as well to help get you through some of these challenging questions. So we're almost there. Let's just wrap up this fourth and final approach. We already hit on this kind of like pro-con analysis, but just quickly, the class-based syntax isn't ubiquitous yet, but like it's getting there. It's increasingly emerging as the new standard. And it also very intentionally feels more like the style of some other popular programming languages like Python. And that can be really helpful in terms of code readability and just general technical communication between engineers from different backgrounds who may be working on the same team. In terms of problems, I love the problem here. 99% of developers have no idea how it works and therefore fail interviews, but you won't be one of them. And that's true, actually. One of the biggest downsides of class syntax is that it abstracts away a ton of manual work. So if you don't know what's being abstracted away, it's very easy to get lost in this class-based syntax. But when you're able to understand what's actually happening under the hood, it makes it a lot easier to read and reason about class syntax and to appreciate the ways that it simplifies our lives as JavaScript developers. Now, I know that we covered this fourth approach more quickly, but thumbs on solution number 4, thumbs on this like syntactic sugar of classes. How do we feel about this? Pretty good, right? Love me some syntactic sugar. Christian, is that a question?
Yeah, would we add methods in the same way as the last portion, since you were saying it's pretty much the same, it just abstracts a lot of what we did?
Yeah, so the way we can add methods is just like this. Inside of our class, like you notice these outer curly braces don't end until this line down here. So we define methods outside of our constructor function, but inside of our class, and they're automatically populated on that prototype object for us.
I guess I mean, could we use the user creator dot prototype to create new methods if we wanted to down the line add more functionality?
Yeah, that's a great question. You totally can still access using dot notation. You can still target that prototype property and add additional functionality to it. By convention, generally, you will see methods instead added to the class itself. So if we wanted to add another logout function here, by convention, we would just add it here with some functionality on it. But we could also just to have all of those methods all together so that we're very aware of what's populating that prototype object. But yeah, you can also access the prototype property directly and populate it with additional methods.
Okay, cool.
Cool, great question. Ryan, what's up?
If you were wanting to add a property to the prototype, and you were looking to do that in the class, would you do it the same way, or would you have to go through the dot notation?
How do you mean? Like if we wanted to add an additional method like this logout method here?
Instead of a method, have it be a property.
Oh, yeah, to
like a
add
counter,
additional
for
data, you
instance.
mean?
Yeah.
Yeah, so to add additional data, the constructor function is generally instead what we populate. So if for a user, we also wanted to track like their age, then we could add an additional parameter here called age, and then simply use this .age to prescribe that passed in piece of data to a property on this object.
Not necessarily on the prototype object, not on the final object. So say you wanted a counter to count the number of instances of that reference the original.
I see. So if you're dealing with a different piece of data like that, generally speaking, we want classes to be very modular, which is to say we want them to deal with a particular subset of data in our application. So if our users wanted to be accessing some counter property that's external to the user data itself, we would likely store that in a different location versus something like you said like if the counter property was specific to a user, then we would probably have it here in the constructor function. If it was some counter that we wanted associated with this one user, we would probably store that here. We'd pass it in as an argument and we'd store it in the constructor function here. But if it was some kind of counter that we wanted to be sort of globally available to all of our users, we simply wouldn't store that within this class. We'd store it somewhere else in our application that our users would also have access to.
Okay.
That makes sense, as opposed to using the prototype object, which the whole goal of that prototype object is to provide functionality that should be shared across many user objects.
Okay.
For sure. Yeah, absolutely. Thank you so much for the questions, and thank you all for the questions, for volunteering, and for hanging out with me on this Thursday night. It was awesome to meet y'all. I will hope to see you at workshops in the coming weeks and to see some of you here on the East Coast. If you've got any follow-up questions after this workshop, things you didn't think of here or just don't want to ask right now, feel free to find me on that CSX Slack workspace. I mean, you can see my name here, Ryan McDaniel. So if you've got any questions you didn't have the chance to ask tonight, feel free to shoot me a message there. But I hope you all have a wonderful rest of your Thursday night, and I'll look forward to seeing you around.